Hello everyone and welcome back. So in this session, we'll explore the essential of designing the Android user interfaces using the layout. We'll understand the layout types and the important user interface components. Then finally, we'll discuss how to build the adaptive designs. So these all are we are going to discuss in this particular session. So let's get started. So the first we'll understand about what are Android layouts. Android layouts define the structure of the application user interface. They act as a container that hold and arrange the views like buttons, images and the text fields on the screen. So, the layout determine how these elements are displayed, sized and positioned relative to each other and the screen. So, they are categorized into two main components. So, one is a view and another one is a view group. So, the first we will see about what is a view. View is a smallest building block of a Android user interface. It represents a single user interface element that users can see and interact with. However, the views cannot contain other views as they are self-contained user interface elements. Actually, the views include the widgets like text view for displaying the text and the button view for the user actions, and the third is image view for showing the images and edit text for the user input. Each view handles its own layout, drawing and the interactions behavior. So, for example, a button knows how to display itself and respond what tapped. Then second is a view group. A view group is a invisible container that holds other views or even other view groups also, and it defines how those children are arranged on the screen. It acts as the layout manager for its children. And the common view group include the linear layout, so which aligns the children in a single row or column, and the second we have a relative layout. So this will position the children layout to each other. And the next one is a constraint layout. So in this case, the positions elements based on the constraints. And we have a frame layout. So here it will stack the children on top of each other. Then we have a table layout. So this will organize the children into rows and columns. So view groups can nest other view groups to support the complex user interface hierarchies. For example, a linear layout may contain the relative layout, which in turn holds the multiple views. So next we will see about the various types of user interface layouts in Android. So here we have 5 primary types of the layouts in Android. The first one is linear layout, second relative layout, and next frame layout. Then we have a constraint layout. Finally, we have a tablet layout. Then let's see one by one. So first we'll see about the linear layout. So this view group aligns all of its children in a single direction, either vertically or horizontally. The Android orientation, this attribute specify the layout direction, and setting the Android orientation helps specify if the child views are displayed in the row or column format. Okay. Then second one is relative layout. So this particular layout is a view group that places its child view relative to one another. Each view locations can be set relative to the sibling components, such as to the left or below the another view, or relative to the relative layout area of its parent, such as aligned to the bottom or left or center. Okay. Then third one is frame layout. The frame layout is designed to display the single object in a section of the screen. In general, the frame layout should only be used to host the single child view, as it can be difficult to organize the child view in a manner so that is scalable to various screen sizes without the children overlapping. So nevertheless, You may add the several children to a frame layout and manage their position by providing the gravity to each child using the Android layout gravity feature. Then we have a fourth option, constraint layout. So, the constraint layout permits the creation of the complicated layout with a flat view hierarchy. So, flat view hierarchy is about no nested view groups are there. So, it is similar to the relative layout in that all the views are set up according to the relationship between the sibling view and the parent layout. But it is more flexible than the relative layout and easier to use with the layout editor in the Android Studio. So, because of the layout API and the layout editor were the purpose built for one another. So, all the power of constraint layout is accessible immediately from the layout editor visual tools. So, the developers may construct the layout with the constraint layout using only the drag and drop instead of writing the code in XML. Then a fifth option is Android table layout. So, table layout is a view group that presents its children in the rows and the columns, and table layout arranges its children into columns and rows. And table layout containers do not display the row, column and cell borderlines. So, the table will have same number of the columns as a row with the most cells, and the table can leave the cells vacant. As in the HTML, the cells can span the multiple columns in Tableau. At the same time, so the developers can spam the columns using the table row span field. So, we have a class layout parameters. So, there are the different attributes of Android layout is there. Then the Android layout contain the various attributes that control the user interface, components, positioning, size and appearance. So, these attributes allow us to manage the placement, spacing and the alignment of elements inside the layout.